All right. Do you have any questions about any of the problems that you were supposed to factor in either section? Do you have anything that you went back and looked at in 5.5 and had a question about? How about 5.6? I love y'all. Y'all are just going to come in case I say something important, whether you have any questions or not. Does silence mean I've done the 5.6 homework and I'm okay with it, Kelsey?
Yes.
How about you, Evan?
What I was going to say is I think we could probably do a couple more examples. I think that would.
I think that's reasonable. And I kind of want to show you what they're going to look like on the worksheet anyway. So just glancing at the evens on page 391 in some edition, I'm not sure what edition. Let's look at 48. I'll do maybe a cosecant and a cotangent if y'all would like to see a couple more. And I'll pick the ugliest ones there, the ones that have the most shifts and translations, etc. All right, I'm going to grab that handout so I can see the way I've labeled the parts on it. The first thing that I ask is that you rough sketch one period of the graph, and in the instructions, I have what I'm talking about when I say rough sketch. Remember when you're graphing in MyMathLab, they had this shape for you to click if you were graphing one period of sine, and this shape to click if you were using one period of cosine. They didn't have tools for graphing tangent, cotangent, secant, and cosecant, but I drew an image of what cotangent kind of looks like, what polynomial function in one period. What does it look like?
X cubed.
Mm-hmm. And cotangent, I did say tangent, didn't I?
Mm-hmm.
Okay, tangent kind of looks like x cubed. Cotangent kind of looks like what polynomial?
The negative x cubed.
Yep. And then secant and cosecant both have a concave up UE and a concave down UE. So that's what I mean by rough sketch. Just draw me a picture of showing me that you know what this graph is supposed to look like on one period. So in this A part, and by the way, just in case anybody's watching this on YouTube and you don't have the ability to print this handout, just write down what I'm writing down and take a picture of it. You don't have to send me a picture of the worksheet. The rough sketch that I asked for in the A part, I know secant and cosecant both have that concave up and then that concave down U shape. And then I ask you for the amplitude of the function. So I actually ask amplitude on, no, I took amplitude off of secant and cosecant because amplitude only applies to sine and cosine. All the other four trigonometric functions go from negative infinity to infinity, except for secant and cosecant's missing some of the middle. Anyway, amplitude only applies to sine and cosine. So the next thing I would ask you about cosecant is what's the period of this function? In general, how do you find the period of any trigonometric function?
The 2 pi divided by the coefficient of x.
Is it always 2 pi? Think about tangent and cotangent. What's the period for tangent and cotangent? Evan, do you remember?
I'm trying to think.
When we graph tangent, we said it has vertical asymptotes wherever sine is 0. And where is sine 0? Whole pies or
Okay.
half pies? Where is y 0 on the x-axis or the y-axis?
Wait. I think I'm misunderstanding the way you're asking the question.
And that's not surprising. Every once in a while I ask something poorly worded. I'm going to keep labeling these 4 quadrantal angles in my on my unit circle, just because it helps me to have something to look at. You know, I can't squint and see things in my head. So I'm going to label these 4 points. And I got off topic just a little bit. This problem is about cosecant, but remember I asked the question, how do you find the period for any trigonometric function? And Kelsey said 2 pi divided by the coefficient of x, which is almost always true, but not always true. Actually, let's say it's right 2/3 of the time. For 4 of the trigonometric functions, you're right. You would just take 2 pi and divide it by the coefficient of x. But the 2 functions that don't have a period of 2 pi are tangent x and cotangent x. And we were trying to figure out their periods so that I could go back and correct what Kelsey said about the period of any trigonometric function. So for tangent, I said it's 1 over sine. So it has a vertical asymptote wherever sine is 0. And where is sine 0 on the unit circle? Which coordinate is sine?
Sine is y.
Okay. I wish you didn't have that question mark in your voice, but you're right. Sine is y. And is sine y on the x-axis or the y-axis? I think I said that wrong. Is sine 0 on the x-axis or the y-axis?
On the x-axis.
Right. So tangent has its vertical asymptotes at the half pies. And to be technically correct, I'd have to say odd half pies. And cotangent has its vertical asymptotes wherever x is 0. You know what? You said the exact right thing, and I wrote the exact right thing. Okay, that's right. Tangent has its asymptotes at the odd half pies. Cotangent has its asymptotes wherever cosine is 0. What? Dang it. What am I thinking? Are y'all totally confused now?
Well, I just thought tangent was like sine over.
It is. I don't even know what I'm writing. Okay, I'm just gonna edit that out of the video. Dang. Maybe that's why you were having trouble answering that question, Evan. I was completely lost my mind for a minute. Now that I have it written correctly, I could say tangent is sine over cosine, so it has its asymptotes wherever cosine is 0 and cosine is 0. Cosine's your x's. X's are 0 at the odd half pies. So that's where tangent has its vertical asymptotes. Cotangent is cosine over sine. So it has vertical asymptotes wherever sine is 0. That's where y is 0, and that's your whole pies. Goodness gracious, I don't know what was happening with me there for a minute. Is that okay despite my blundering?
Yeah.
I think I get it now.
Okay, I am so sorry. I have no explanation other than I may have still had cosecant on my head. I don't know. So, Miss Kelsey, all I wanted to say, the way that we got off, that's hard to say we got off on a tangent. Literally, we did get off on a tangent. the way we got off on this is I wanted to correct what you said about how to find the period. It would not be correct to say that for any trigonometric function, you divide 2 pi by the coefficient of x. It would be correct to say you take its normal period and divide by the coefficient of x. Now for sine, cosine, secant, and cosecant, the normal period is 2 pi, so you'd be right. But for tangent and cotangent, their normal period is 1 pi. So you would take just pi divided by the coefficient of x, not 2 pi. Does that make sense, Kelsey?
Yes.
Okay, all right. So this period is 2 pi divided by the coefficient of x. And the way you divide by a half is multiply by 2. So 2 pi times 2 is 4 pi. That's the period of this function. And then I believe I ask you for the left and right asymptotes. And the directions say, solve the appropriate inequality. I want to know that you know how to find the left and right asymptotes of one period of cosecant. So I'm thinking, where does cosecant normally have its vertical asymptotes? Whole pies or half pies?
That'd be half pies.
The half pies, because that's where sine is 0. Oh, no, it's not. The half pies, sine is 1 or -1, so cosecant would be 1 or -1. Cosecant has asymptotes where y is 0, and that's on the x-axis, or the whole pies. Does that make sense, Evan?
Yeah, I was just mixed up like you. I thought sine was 0 at half pies.
Okay, all right. And this helps me so much. I mean, it's a very quick thing to write down, but I need to look at it and say, where is sine 0? That's where y is 0, and y is 0 at the whole pies. So I would take this argument and set it between 0 and 2 pi, because those are what we use for the left and right vertical asymptotes in one period of cosecant that hasn't been shifted. So I solve that inequality. I add pi over 4 to all 3 sides. That's 8/4 plus 1/4 is 9/4. And then multiply all 3 sides by 2. And I can double check that that period really is 4 pi. That's a good built-in check for my inequality that I solved. If I subtract the left end from the right end, I should get 4 pi. This is 9 halves minus 1 half is 8 halves, and 8 halves is 4. So that period is 4 pi. That built-in check is nice because it's easy to make a mistake solving that inequality when you're adding fractions and multiplying. That's your left and right asymptote. And in the D part, I ask you for the middle asymptote. How do you find what's halfway between pi over 2 and 9 halves pi?
Add them and divide by 2.
Absolutely. So 1 half plus 9 halves is 10 halves. Halfway between those would be 5 halves pi. So x equals 5 halves pi. Now I forgot to say something on the C part. the C part says solve the inequality and write your two answers as equations, because we're looking not just for numbers here, we're looking for asymptotes. So one of the equations is x equals pi over 2, and the other equation is x equals 9/2 pi. So I have my left and right asymptote and my middle asymptote. And the only thing I ask you to do after that is just graph the function. I'm going to put on the handout, I say, I just give you a blank graph like that and tell you to label at least 2 tick marks on your X and your Y axis so I know what you're counting by. So I'd label the first one 5/2, or excuse me, pi over 2. That's 1/2, 2/2, 3/2, 4/2, 5/2. I'll go ahead and label that one. And then 6/2, 7/2, 8/2, 9/2 pi. That's where I have vertical asymptotes. Oops. It also helps if you label your tick marks carefully. You can see you have 3 tick marks between pi over 2 and 5/2 pi, and you have 3 tick marks between 5/2 pi and 9/2 pi. So you know that you found that middle asymptote correctly. It is exactly halfway between pi over 2 and 9/2 pi. Then I go back and look at my rough sketch and know that cosecant usually for these endpoints, 0 to 2 pi, it has its concave up UE before its concave down UE. Is there anything about this equation that's going to change that?
No.
What would change it?
A reflection if the coefficient in front of cosecant was negative.
Ooh, you said that so well. If that had a negative coefficient, then this would be concave down before concave up. But I don't have a negative coefficient. Is there anything else about this problem that changes the graph from what cosecant normally looks like? What does the 4 do?
Does it make it just more narrow?
You know what? I forget to say this sometimes, but if you're ever unsure, you can make an XY table just like you can for any function. We're trying to avoid doing that, but let me just say right here, I'm totally confused. I don't know, I'm not sure what that 4 does. I can pick, let's see, what's halfway between pi over 2 and 5/2 pi? That would be 3/2 pi, right? What's a half of 3/2 pi? A half of 3/2. It's a half times 3/2. Ooh, y'all need to work on your fractions. What's a half times 3/2?
Would be 3/4.
Yeah. So that would be 3/4 pi minus 1/4 pi would be what?
That's just 2/4 pi, so 1/2 pi.
Right. So if x is 3/2 pi right here, this would just be a half pi. Now, what is cosecant of a half pi? Well, what is sine of a half pi?
1.
And so what's cosecant of a half pi?
1 still.
1. And what's 4 times 1?
4.
4. So that just gives you the turning around place for the concave up UE. It turns around at 3/2 pi, comma 4 instead of 3/2 pi, comma 1. And the same thing about 7/2 pi. We won't go through that whole thing again, but it's going to turn around at 7/2 pi negative 4 instead of 7/2 pi negative 1. And that's exactly what I'm going to ask you for on the graph of cosecant. I'm going to ask you for the rough sketch and then the period, and no matter what trig function I give you, you just take its normal period and divide it by the coefficient of x. And then for secant and cosecant, I'm going to ask you for the left and right asymptotes. I'm going to say solve the appropriate inequality. Now, if that had been, we're not going to do this problem all the way, but if I had said find the left and right asymptotes and gave you y equals, let's say, secant of 1/3 x plus pi over 3. Let's just do the C part of that problem. You would have to think, well, where does secant normally have its asymptotes? To figure that out, you look up here and say, well, secant's the reciprocal of cosine. So wherever cosine is 0, that's going to be my left and right asymptotes. So where is cosine 0? Whole pies or half pies?
Would it be half pies?
Yep, that's where x is 0, pi over 2 and 3/2 pi. Only when we were trying to just graph one period, we didn't use pi over 2 to 3/2 pi, although we could have. You remember on that summary sheet on the notes what we used for the left and right asymptotes of secant? Instead of calling it pi over 2 to, well, actually, we need one complete revolution of the unit circle. We could go pi over 2. What's bugging me? We could say from pi over 2 back to pi over 2, but that's not what we use. Look in your notes and tell me what we use for that left and right asymptote of secant. Do you not have those notes handy? Do you know what notes I'm talking about? The 5.5, 5.6 notes, we drew all the graphs on the first page. The summary of the graphs was on the bottom of the second page. That's where we got for the left and right asymptote of cosecant, we're going to use the period from 0 to 2 pi. But for the left and right asymptotes of secant, we're going to use negative pi over 2 to 3 halves pi. That's still a period of 2 pi units, but it's your vertical asymptotes for secant are at the half pi's, where the vertical asymptotes for cosecants at the whole pi's. Tell me yes or no, you know where those two numbers come from.
Yes.
Yeah.
Okay, so that's what I need to set this argument between. And solve for x. And again, you got to get good at fractions. You don't want to have to pick up your calculator to punch negative pi over 2 minus pi over 3. You want to look at this and say, that's negative 3/6 minus 2/6 is negative 5/6 pi. How many 6 is 9 halves? Oops, I said the answer, I'm sorry. How many 6 is 3 halves? What would you have to multiply that by to make the denominator be 6?
By 3.
Yep, by 3 over 3. So this would be 9/6 minus 2/6 is 7/6 pi. And then dividing by a third is the same as doing what?
Multiplying by 3.
So multiply all 3 sides by 3. Negative 5 halves pi is less than x is less than. By the way, it doesn't matter if you write less than or equal to. I'm just solving this inequality to get my 2 asymptotes. Oops, typo. Oh, not typo. Now, I said we were only going to do the C part, but I'd like to check that I've solved this correctly. How would I find the period of that function that I gave you?
You would take the 2 pi and divide it by that 1/3.
It's the normal period of secant divided by the coefficient of x. This would have a period of 6 pi. Is this a distance of 6 pi? What's 7 halves minus negative 5 halves? Or 7 halves plus 5 halves?
It'd be 12 halves.
Better known as?
6.
Yeah. So I'm sure that I solved that correctly. I got a distance of 6 pi units between that left and right asymptote. So my directions say, we're looking for asymptotes, right? 2 equations. My 2 equations are negative 5 halves pi and 7 halves pi. Now at this point, we've almost finished the problem. I didn't do the rough sketch, but the rough sketch for secant looks like the rough sketch for cosecant. We have our left and right asymptotes. We have our period. So might as well finish it up. How do we find the middle asymptote?
Add those 2 and then divide by 2.
So 7 halves plus negative 5 halves, or 7 halves minus 5 halves is what? How many
Just
halves? Yeah, 2 halves, which is just 1. So the middle asymptote is just 1 pi. And what would the graph look like? Have those asymptotes at -5 halves pi. My middle asymptote is at 1 pi. And then 1, 2, 3, 4, 5, 6, 7. Let's see, I'm counting by halves. So that's 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves pi. That one's got to be, that's pi over 2. Counting by pi over 2s. To make sure that I have the correct middle asymptote, just count the tick marks between these two, counting 0 as a tick mark, and count the tick marks between these two. This is 1, 2, 3, 4, 5 tick marks. That's 1, 2, 3, 4, 5 tick marks. And if I've used -pi over 2 to 3 halves pi as my left and right normal asymptotes, then secant and cosecant both have a concave up before a concave down. And those UEs turn around at 1 and -1. Is there anything about this problem that changes where they turn around?
No.
No. So they're going to turn around at +1 and -1, and the turnaround is going to be exactly halfway between the asymptotes. So right here for the concave up, and right here for the concave down. Now I said I'd do a cosecant and maybe a cotangent. I ended up doing a cosecant and a secant. Do you want one more with cotangent in it, or are you good?
I think I'm good.
I think so too.
Okay, then let me just quiz you on 2 things real quickly. We won't do it. I said we wouldn't do the problem here, but just let me ask you with tangent, to find the asymptotes, we're going to take the AX plus B, whatever it is, and set it between the normal asymptotes for tangent. The question is, where are the normal asymptotes for tangent?
Is it -pi over 2 and then +pi over 2?
Exactly. Now, technically, we could have used pi over 2 to 3 halves pi, but the reason we use these is because when we use the inverse tangent button on our calculator, it returns us a value between -pi over 2 and pi over 2. So we're just trying to keep that consistent. And then for cotangent, graph of cotangent that's been shifted somehow, what do you set its argument between?
0 and pi.
Right. Okie doke. If you're okay, I'm gonna upload this to YouTube for anybody that wasn't able to join us via Zoom. And then I'm going to, right this minute before I forget it, email you the 6 problems you need to do this weekend. And you're just gonna take a picture of them and send them to me. If you get it to me before Monday, that would be great, but at least by Monday, 9 o'clock. Okie doke.
All right.
Alrighty.
I'm trying to think last night when I sent you a remind. Oh, it was watch the Zoom video for a note about the homework. I thought there were two things, the note about the homework. And I don't know what the second thing was. All right, y'all have a good weekend. Thanks,
You too, Miss
thanks for
Miles.
zooming in.
All right, bye.
Bye-bye.